Alright, so valence electrons. Put a dash here, so I'm going to give you a definition of this. So, valence electrons are just outer shell electrons. So really we're just looking for the number of electrons in the outer shell of the atom. So for example, let's say I had magnesium, atomic number 12. If I, let me write the electron configuration first. So it's 1s2, 2s2, 2p6, 3s2. So there's my 2, 4, 10, 12 electrons. Right? And then if I draw this thing, it's going to look like this. 12 protons, 12 neutrons. There it is. So, looking at the drawing, I have two valence electrons. Just the electrons in the outermost shell. So why do we care about valence electrons? That's the real question, right? So, basically, all chemical properties or more or less all of them, just about all of them, depend on the number of valence electrons. If I say what something reacts with and how it reacts, most of that depends on how many valence electrons an atom of that element has. So in a way, everything I taught you, atoms, neutrons, protons, electrons, all this stuff has really been leading up to you knowing how many valence electrons are in each atom. For this drawing, I don't really care if it's 2882 or if it's 22. It's this part, only those outer two electrons that really matter, right? So if I look at calcium, let me just draw that for a second, which is going to be 2, 8, another 8, and 2, right? Here's calcium, here's magnesium. The inner shells aren't all the same, but the outer shell is the same, and calcium and magnesium behave almost exactly the same. They react with the same elements, they're found in the same places. If you find calcium, you usually find magnesium with it, and vice versa. They're very, very similar because the outer shell is similar. The rest of this stuff doesn't really matter that much. It matters a little bit, very little. Okay, one last thing. If you want to calculate the number of valence electrons, of course you can draw it. The other thing you can do is you can look at the electron configuration. You find the highest number, which is 3 in this case, right, the third shell, and then you just find the number of electrons in the s and p orbitals of the highest number. We'll say another way to find the number of valence electrons is to add up the electrons in the highest number S and P orbitals. Whatever the highest number, shell number you see in the electron configuration is, you look at the s orbital of that shell, and if there's a p orbital, and you add up the electrons in those two. All right, so let's do an example of that. I guess I'll erase here. Let's do something like gold. Okay, let's do gold. So gold is atomic number 79. So if we write the electron configuration, 1s2, 2s2, 2p6, 3s2, 3p6, that's 18 so far, a long way to go. 4s2, 3d10, 10, should be going to 10, 4p6, 5s2, right, screw myself in my 5s2, 4d10, 5p6, 6s2, 4f14, and finally it's going to be 5d9, right? Yeah, 5d9. Okay, so what we look for here for gold is the highest number shell number, and then we look for any s and p orbitals with that number. And by strange coincidence, maybe not coincidence, it's going to have 2 valence electrons, just like the other ones I said. Right? Because look, 6s2, and there is no 6p. And if we draw gold, since we did this, we might as well draw it. It's going to be 2 electrons in the first shell, 8 electrons in the second shell, 18 in the third shell. Fourth shell, we've got 4s, 4p, 4d, and 4f. Add up all those, that's 32. Fifth shell has 5s2, 5p6, and 5d9. That's 17. And then the sixth shell, 6s2 is 2 electrons. So there we go. There's our 2 valence electrons. Now, it's kind of unfortunate that I gave you 2 examples of the same number of valence electrons. So let's do one more. Let's do, I don't know. What about bromine? That's a good choice. Thanks for picking that. What was it? Bromine. Bromine's 35, right? 35. So bromine be a little bit easier to do. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4s2, 3d10, and 4p5. There we go. So short. So how many valence electrons is this going to have? Well, you look at the fourth shell, because that's the highest number, right?
7.
It's going to be 7, 4s2 and 4p5, right? So that fourth shell is going to have 7 electrons. Now we could draw it just to show that. 2, 8, the second shell. Third shell is going to be 18. And then the fourth shell is going to be 7. That's 7 valence. And that's all we really care about today, is just how many valence electrons. Questions on this?
Nope.
All right. So you guys have had like a week off, so you know if you're not getting this, you should be going home watching these videos, and always making an effort to figure it out. Plus the days when I'm not here, you can get help from the other students and stuff. If you didn't, we'll get you caught up. All right. I guess that's it. This would be an easy worksheet. Likely, you gotta do that thing.